Welcome to the math record. In this video, I'll be using Euler's method to approximate next points using previous points. So basically what Euler's method is doing is that given a derivative and a initial point, how do you get to the next point even though you don't have the function for that derivative? So basically, Euler's method is similar to Newton's idea where we're using a recursive method to get to the next point. So Euler's formula is actually just f of x for the next point, so n plus 1 sub n plus 1 is equal to our current point, which is f of x n plus a stepping size, which we call h, multiplied by the derivative of our function at that point. Okay, so this process is really tedious, but basically you're just going to complete a table given some values that you're going to be looking for. So 2, 3, and 4, 5. Okay, so let's delete a bit of this so we could write some problems. So the first one that we're going to keep track of our x and our y, obviously, for our points. The next one we're going to keep track is our derivative, this. And then the next one we're going to keep track is this, so h times our derivative of y. And after that, this point is our y, so it's going to be y plus h times the derivative of y. Okay, so following that formula, let's use an example. Let's say f of x. Let's say we're given a derivative is equal to 3x squared minus 5x plus 1, and you're giving the point f of 0 is equal to 1, and you want to find f of 0.5. Okay, so let's choose a stepping size. Usually I like to have at least 5 numbers, so let's say 0.5, we're going to go by a stepping size of 0.1. So 0.5 divided by 0.1 equals 5. Or if you want to use a less stepping size, you could say h is 0.25. So you only do the calculation twice. But 0.1, we have to do it 5 times, or 4 times technically. But here's what we do. We start with our x, which is 0. We start with our y, which is 1. Okay, what's our derivative of y at 1? Well, at x equals 0, when we plug it in, 0, 0 plus 1 is 1. Now what's our h? Let me write that back again. Our h we said was 0.1. So 1 times 0.1 is 0.1. Now our y plus a h times derivative of y equals 1.1. So following this formula, basically what we did is that we have our x, we plugged it in to get our derivative, which is this. We multiplied it to our stepping size to get this, which is this. And then we added this to our current y value to get our next y value, which is this. So basically, to get to our next x, we just step size. So 0 plus 0.1 is 0.1. And then this is our next value for our y. So that means at point 0.1, the y is approximately 1.1 using Euler's method with a stepping size of 0.1. Okay, now we do the process all over again. So plug in 0.1 into our derivative of y. So usually when you're doing Euler's method, you're going to use your calculator because doing this by hand is really long. And this is really a tedious process already using this table. I mean, Euler's method is in general really tedious. So when you plug it in, you should get about 0.53, and then 0.53 multiplied by 0.1, which is our h, is 0.053. Add 0.53 to 1.1, and you get 1.153. And step size your x, so 0.1 add to 0.1, 0.2, and our new y value is 1.153. So plug in 0.2 into your derivative, so you get your next derivative. And we're doing this process all over again, so that's 0.12. So you're putting this in your calculator. So 0.12 times 0.1 is 0.012. 0.012 added to your y value to get this value. So you get 1.165, and then step size your x, so 0.3. your y is 1.165, and then plug 0.3 into your equation to get your derivative, and then that gives us a zero, sorry, a negative 0.23, and then negative 0.33 multiplied to our stepping size 0.1, which is negative 0.023. Add this to get your new y value, which is 1.142. Step size your x, which is 0.4, so that's 1.142, and plug in your 0.4 into your derivative to get your next value. As you see, this is really tedious, and this gets negative 0.52 multiplied by your stepping size to get your h times your derivative y, so negative 0.052. Add this value to this value so you could get this value. So we get 1.09. That means 1.09 goes here, and that gives us 0.5. So that means 0.5, our y value is 1.09, and that is our answer. So as you see, this is a really tedious process, and you would use your calculator a lot. But I already had the numbers beforehand in a chart, so this is I was basically showing you the method of how to do it. Well, thanks for watching. In the next video, I'll be covering related rates. Okay.